Hi everyone, Dr. J here, and in this video we're going to continue working on through this Introduction to Python notebook. And one of the things I want to point out is that sometimes if you open up this notebook in Google Colab, you'll see that you'll have this little arrow here next to the main name of the section, and you'll see several cells are hidden. So what we can do is just click that black arrow to show all of those cells. Alright, so let's continue on. So we've talked about numbers and objects and classes a little bit. We've talked about strings. And now this section is going to go into strings in more detail. Python, as it says, Python can also manipulate strings. Strings can be enclosed in single quotes or double quotes with the same result. Use backslash to escape quotes, that is to use a quote within the string itself. I'll also point out that if you want to do something like this, where you have an apostrophe, you can use double quotes, and then a single quote on the inside won't be a problem. Same thing if you use single quotes on the outside and double quotes on the inside, although of course in this case that wouldn't work. Sorry, so let's just go down through here and run each one of these cells. So spam eggs. You see the single quotes there on either end of the string, and inside there can be spaces, there can be really anything. And it will print that. Okay, so here we're going to use a backslash to escape the doesn't, the apostrophe there, and it will print out that string. Or if we use the double quotes on the outside, that's the same effect. You can see that we can use double quotes inside the single quotes, as I was just saying a second ago. There we go. And by the way, so when you see these single quotes on the outside, that just means that those are delimiting the string that you input. Those are not part of the string itself. The print function produces a more readable output. Right, so let's just go ahead and say print that whole thing. And now we have the actual string itself, as opposed to just the Google Colab console printing out whatever string we input. All right, and this is that same example we just ran. There we go. These \n means a new line. So you can see if we use the raw string, that's what it looks like. But if we print that, then we have first line, second line. All right. So if you don't want escaped characters to be interpreted as special characters, use raw strings by adding an R before the first quote. So here we go. Here's an example using some path name for a computer, and by using this R, we can just interpret it as a raw string. So in this case, those backslashes would normally be interpreted as escaping something. String literals can span multiple lines and are delineated by triple quotes. So here's another way to define a string in Python using these triple quotes, and I'll let you go through and look at this. Python doesn't provide a means for creating multi-line comments, so developers often just use triple quotes for this purpose. In a Jupyter Notebook, however, such quotes define a string literal, which appears as the output of a code cell. So if I run this cell, which has these triple quotes on either side, this whole thing looks like a raw string, basically, when in reality, most people use these kinds of strings as what's called doc strings, where we're talking about documentation for a function or whatever. Strings can be concatenated, glued together with the plus operator, and repeated with the multiplication operator. So here is a case. This is the first case that we've seen so far that illustrates what's called overloading. And overloading is a concept in programming where the same thing can do two different operations depending on what the inputs are. So in this case, so normally with numbers, obviously 2 plus 2, that's going to give us 4. But here, if we say 3 times un, that's going to repeat un 3 times, plus eum, you see this kind of, well, whatever this word is, you see it there. 2 or more string literals placed next to each other are automatically concatenated. So you've got 2 strings right next to each other, they just get concatenated. Automatic concatenation only works with 2 literals. It does not work with variables or expressions. So the following cell produces an error. If prefix equals pi, and then you try to say prefix and thon, that's not going to work. And so we get an error. And the following cell also produces an error, where we have a string times 3. That part will work, but then we have these parentheses, and that's not going to work. Okay. To concatenate variables or a variable in literal, use plus. So in this case, we have a variable and we're adding on to it. We can use the plus and that will work just fine. Automatic concatenation is particularly useful when you want to break up long strings. So we can just have a string here. In this particularly long string, we can break it up into several lines. And then we can print that and that'll work fine. All right, so in this section, now we want to just demonstrate how you can reference strings. So strings can be indexed with the first character having index 0. So a single character can be pulled out of a word by simply using integer indexing. And in this case, a word acts as a list of letters that are all put together. And so you can pull out the 0th letter or the 5th letter, which is actually the index 5 letter is the 6th letter in the string. -1 is a special index in Python. And actually, negative indices can be used in general, and they count from the end of the string. So -1 is actually the last value in the list, normally, because this is a word. It's the last letter in the word. -2 is second to last. So in Word, by the way, our word is Python here. So word is Python, second to the last character is O, and so we can evaluate this and we get the letter O. And this works all the way back to the beginning of the word. So we can index a list of items, including a word, negatively or positively, from the end of the word or from the beginning of the word. We can also use a colon to index several letters in a word. So word 0 to 2, that's going to give us the first 2 letters. You notice our index is 0, 1, and 2. So 0:2 is the equivalent to 0, 1, and 2. But Python has this interesting characteristic where it only takes up to the last index, but not including. We can do the same thing here, 2 to 5, and so on and so forth. If we try to use an index that is too long, it's outside the length of the word, we'll get an error. And again, we're looking at these errors. We're looking at the location of the error from this arrow here, and it's in just a reference. We only have one line here, so that's just that line. And the last message that we get is an index error. The string index is out of range. So we've tried to index a word, which only has 6 characters, with the number 42, and of course that's not going to work, and so we get this error. If you use a range, the index that's too large defaults to the size of the string. So if we say 4 to 42, that works. And if we say 42 and on, we get nothing. So in other words, you can use this type of functionality if you don't necessarily know the length of your string. You can just say from some number on, or as we see here. Once you define a string, Python has this concept of immutability, which means unchanging. And certain types of data objects in Python are immutable, which means they cannot be changed, as it says here. And certain types are not immutable. So lists, for example, are not immutable, but strings are immutable. So if you try to change a value in a string, you'll get this error, a type error. String object does not support item assignment. Remember, the equal sign is an assignment operator. So if we try to take a word that already exists and make the first letter of that word J, that's going to give us an error. And the following cell also produces an error because it's the same thing. We're trying to assign a certain number of characters to be the letters PY, and that does not work. So we can take a slice of the word, which is just from 1 to the end, a subset of that word, and then add on the letter that we want to add, and that will work. Okay, and I'll let you look at the rest of that there. All right, so now we've already talked a little bit about lists, but let's look into them in more detail. This is called, this says compound data type, a type of object which holds other objects or other values. And the most versatile is the list, which can be written as a sequence of comma-separated values between square brackets. Lists might contain items of different types, but usually the items all have the same type. So here we go. Here's our first list, squares. Actually, a word is a kind of a list, but this is the more proper list in Python. So here's a list, squares equals. So we're assigning this list to the variable name squares. We do that, and we can print out the value of squares, and so here we have a list. Notice that each one of the entries in the list are themselves Python objects. So this is a Python object. This list is a Python object which contains other Python objects. And if we print the type of squares, you'll see it's of the class list. So this variable squares is now holding an object, a Python object, an object of the class list. However, if we index into that list, which we can do, and I'll just drop down here. So there's our list. We can use this integer indexing as we did with strings on the list. So the first item is going to be indexed with 0. And we can look at the type of that item. So now here's this first item. We're going to look at the type of that item, and it's of class int. So this list is a Python object which is holding objects of different types from itself, that is. So again, we can index the list just like we index a string. And here we are, we're doing that. We can index a slice. And by the way, slicing is a particular term to Python programming. Sorry, it's a particular term to programming, and it just refers to a subset of the new list. So in this case, we're taking the last 3 elements of the list squares. And all slice operations return a new list containing the requested elements. This means that the following slice returns a new shallow copy of the list. So if we use this colon operator, that just takes everything in the list. Whoops, and I've made a typo here. So the colon operator takes everything in the list, and it returns a copy of that list. We can also add 2 lists together, and that will actually concatenate the items in the 2 lists. So now we mentioned that strings are immutable, but lists are actually mutable. What that means is that they can be changed. We can assign new values to the elements in a list. So for example, here we have cubes. We've got something wrong here. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is actually 64 and not 65. And so what we're going to do is we're just going to replace the wrong value, 0, 1, 2, 3. This is the 4th element in the list, which is indexed with the number 3. I'm sorry, I know that's a little confusing. That's just the way Python is. We start counting from 0. So that's why the number 3 is here instead of the number 4, because we're starting counting at 0. So we'll replace that, and now we have our cubes list, and now we have a list of perfect cubes. We can add a new item to a list using the append method, and a method is a function or an action that goes with an object. So remember, all things in Python are objects, and so objects have their own methods. So this cubes is a list, which is an object of the class list, and we're going to use the append method to add an object to the end of that list. And there we go. All right, great. So we can assign 2 slices and so forth, and I'll let you go through all of the rest of this. We can look at the length of a list, and actually we can look at the length of a string as well using the built-in len function. So we can look at the number of items in the list and so on and so forth. We can do nested lists, as this says, and if we do that, then we'll use this kind of double, whoops, I need to define it first. So again, here's an error where I've tried to run and access a variable that hasn't been defined yet. So that variable gets defined in this cell. That cell needs to run first. And there's a list of lists, and we can access the first element of that list, which is a list. And we can, so then what I was getting to was we can use this double bracketing notation to access elements of the sublists. All right. So that's it for lists for the moment. And then the last data type we're going to talk about in this video is dictionaries. A Python dictionary is like a a Python dict is like a dictionary, an ordinary dictionary, in that it has keys, which correspond to words, and values, which might correspond to definitions in a normal dictionary. And we define a dict with a curly bracket. So there we go, a dict. Another dict, we can also use a dict or the dict function. And again, we need our open close parentheses there. And that does the same thing. We can assign keys and values to a dict, and they go together. So every key must have a value and so forth. Using this notation. So we have open close brackets, key name as a string, and then the value. So there we have a dict now with 2 keys and 2 values. We can also directly add values, keys and values when we create the dict like this. Here's a third dict, again with 2 different keys and values. And we can access the values in the dict using the keys. So this is where it acts like a dictionary. So we can say, here's our third dict. We can say, again, open close brackets, and we reference the key name. We print that, and that gives us the actual value in the dict for key 2, 10. And in this case, that's a string. We can get all the keys from a dictionary using the keys method. So again, a dict is an object. And in fact, let's just look at the type of this object. So print typed a dict. We run that. So again, a dict is a class dict object. And so that object a dict, has a method called keys. And that basically returns the keys that are in that dictionary and then prints them. And in this case, you can see it's printing them in a notation which looks kind of like a list. So it's essentially returning a list of the keys. We can do the same thing with the values using the values method, and it'll return a list of values. So that basically wraps up our section on Python data types. We talked about numbers, which can be integers or floating point numbers, which are essentially decimal numbers. Strings, which are words and characters. Lists, which are just groups of things. Dictionaries are key value pairs all together. And now we have this section called First Steps Towards Programming. So Python is used by professional programmers and scientists, and is capable of very complicated tasks, more so than just what we've done so far. So for example, we can write an initial subsequence of the Fibonacci series using this expression, this set of statements. So here's the Fibonacci series. For those of you who aren't familiar with Fibonacci series, you can check out the link here. So for a Fibonacci series, the sum of 2 elements defines the next. So you start with 0 and 1, A and B. While B is less than 10, print B. So here B would be 1. But then we're doing an assignment. And you notice a couple of interesting things here. As this first bullet point says, we're doing what's called multiple assignment. So A is getting mapped to B. B is getting mapped to A plus B. And this is, of course, the classic Fibonacci series. A goes to B goes to A plus B. And then we iterate. So for A and B equals 0 and 1, A goes to 1, B goes to 1. For B, A and B both equal to 1, we have A is equal to 1, B is equal to 2, and so on and so forth. So let's run this. And now you can see we've printed out B, which is the next number in the Fibonacci sequence, all the way up to B less than 10. So 1, 1, 2, 3, 5, and 8, and you can already recognize the classic Fibonacci sequence. What we're doing here, though, is we have this while loop. So this is our first steps towards programming. Using a while loop, we can loop through this sequence of statements. So these two here, print B and AB equals B, A plus B. We're going to repeat those 2 statements, and we're going to keep going until this statement is no longer true. So this is just like English. While B is less than 10, we're going to do these 2 lines. And you notice that there's an indented block here. The indent is important because it tells Python everything that's inside of this indented block is going to happen while inside the while loop. Whereas, for example, let me just write a little statement out here. Print a final statement. Notice that even if I take away the space, a final statement does not get printed until the very end. And that's because only the indented lines are being run in each loop. And it's basically executing this indented block of code, and it's continuing to do that until something happens which makes it not do that. Let's go ahead and just change this criteria here to be less than 100. And now you can see we've extended the loop. In other words, the while loop kept going until it reached the higher criteria of b less than 100. So we've continued to assign that, and if we end up here, and actually let's do this. So let's go outside of our loop and print b, because you can see what's happening right now is that print b is happening before the assignment. So we're going to add this print statement outside the while loop. See, it's not indented. And so it's going to end up printing the last value of b, which is greater than 100. Let's go ahead and run this. And now here's our full sequence. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and 144. So b gets printed at the end. It got printed here before the assignment, and so we didn't get that last value of 144 because there was no more print b statement. Once we reached 144, while b is less than 100 is no longer true, and this indented block of code doesn't get executed. Okay, so if that doesn't make sense, go ahead and rewind the video and listen to that again. Hopefully it should make sense. This while loop, while b is less than 100, that's the criteria. And you notice this is a logical criteria in this, I'll put it in parentheses. So while b is less than 100, that's a logical true or false statement. So while true, it's going to execute this code block. And while if that becomes false, none of this code block will be executed again. If we say b less than -1, what do we have? We have 1. So what happens is b is already greater than -1 when we start out. B is equal to 1. So because of that, we don't actually do anything inside of this. There's no assignment at all that happens, and we just print out b at the very end. Okay, so hopefully that is starting to make sense. And let me just make sure I covered everything that they have written here. You can go ahead and read through this yourself. Right, so we're using the print statement because we don't want to, if we didn't use the print statement, then we wouldn't see what the value of b was at each step because it only prints out the very last thing. And so that's already something we've talked about. Now here's an interesting case where we can use where we can put a value that we don't know into a string. And this is very useful when we want to have a program that prints out a result for us. And so in this case, we have some value I, and we're just going to print out what that value is. And this is a very simple kind of a string. Another way to do this, which is what I normally like to do, is to say the value of I is two print statements, and they look different. This one definitely looks more complicated, but it results in the same thing. So in this case, we're formatting I and dropping it into these curly braces. Here we're just concatenating the value of I to the end of the string. Now you might say, why would you ever use this instead of this? This is so much simpler. And the reason is, and the reason I use this particular form in almost all cases, is because Python is able to do more complicated things than just print out this number. So if we wanted to format this number to, say, have 2 decimal places, or have leading zeros, or have a fixed number of digits, perhaps we have things that aren't just simple numbers, but are more complicated Python objects. So format handles all of that very nicely, and then that allows us to be very generic when we're doing print statements. So we don't have to necessarily know what I is. We can just write a generic print statement and make it however we like it. And we'll possibly learn how to do more of that later on. Okay, so that's for that. The keyword argument n can be used to avoid the new line after the output or end the output with a different string. So if this is just kind of a detail, I'll go ahead and run that. But basically, right, so you can do this with commas using this keyline end in the function print. So this brings up a good point, actually, which is that Python functions can often have optional arguments. In fact, let's add a code block here real quick, and let's do $print. So question mark, by the way, is you can use in Google Colab at any time in any code cell, and that will give you a help message for this function. And here it is, right over here. So here's the docstring. I mentioned docstring earlier. This is how Python functions are often notated. Print value, and then you see these 3 dots, sep equals, and end equals. And then there's file equals this whole bunch of stuff, and flush equals false. And then the description down below tells you what each thing does. So end is the string appended after the last value, defaults to a new line. Sep is a string inserted between values, defaults to a space, and so on and so forth. So you can use these keyword arguments to add optional effects to your Python functions. In order to find what those are, you just have to do question mark and then the function name. And we can do this with the function type. Here it is. And in this, we have these other things here, which we'll talk about in another video. But arguments and keyword arguments is basically what those two things stand for. And you can see some examples of how to call that. Let's see, and we also saw the dict function, so let's just take a quick look at that. Again, args and keyword arguments. So dict gives you a new empty dictionary, and so on and so forth. So a good way to get Python help with Python is to use question mark and then the function that you are looking at. And let me just close all of that. All right, so that brings us to the end of this Google Notebook. Hope you've kind of started to get the basics of how Python works. Keep going back through this notebook if you need to practice some more. And then there's all sorts of links here where you can learn more about strings, you can learn more about control flows, and so on and so forth. And in the next video, we'll talk about Python functions and how you can define your own Python functions and use them.